Hello, my name is Drew Sheriff, and today I'm going to be discussing Lab 4. So, the purpose of this lab was to compare spring models and experiments to represent energy, Newton's second law, and the momentum principle using GlobeScript. So, these are the two models. On the left we have tracker, and we see the spring bobs around, going left and right. And this video was taken not by me, but was offered by the pre-lecture video. On the right we have the GlobeScript coding representation of this model, and we see how it moves around with that blue line being its path. So the assumptions are that there's no outside forces, no drag, which means it's a closed system, and we're assuming that the values in the pre-lecture videos are correct. Main physical principles in detail are got the velocity update formula, position update formula, Newton's second law, which is dp over dt, the energy principle, and the momentum principle. So the main results was that my model was fairly similar to my experimental. And on the top left we have the energies, bottom left we have positions, and to the right we have the model prediction. So the system is just the ball plus spring, and the surroundings are everything that isn't this ball and spring, so the air, the table, the floor, the person. The initial conditions are there's no velocity, time is 0, and the spring is connected. Where the spring connects to the structure is the origin, not the ball. So, explain the coding details. So the ball mass was given by the pre-lecture video. I used tracker to get the ball position and the ball velocity 0. Gravity, we know that acceleration is 9.8. The spring constant was calculated using tracker. Initial relaxed length of the spring calculated using tracker. Then we have the length is ball position minus spring position. L hats, L divided by mag L, and so on. And then we have some energies at the bottom left, which we know, and continue that up on the top right. And basically, we just use our knowledge of energy and the formulas and apply that to the momentum principle, which we used for the ball velocity update formula and the ball position update formula. The similarities and differences: the experimental has a higher amplitude than the model, and the experimental is a little bit behind in time for the model. But other than that, it's very similar shape. They're pretty close together. I would say it's pretty accurate. Potential sources of error come in plotting the points on tracker, plotting the scale on tracker, and in rounding. So what does it mean? The energy principle is satisfied because as we look at my energy graph, we see that the orange line, which is change in energy, is 0, which means that no energy is being changed in and out of the system. So that means the energy principle is satisfied. And then the oscillation periods are pretty close. The experimental is 1.6 seconds, and the model is 1.75 seconds. And based off that, that's pretty accurate. And it's shown in the graph below.